Hello students, in our previous class we learned how we can find sum of all the terms of a GP. Okay, that means these three formulas. In this class we will learn how we can solve geometric progression related problems. Okay, so let us study how we can solve geometric progression related problem. As a first problem we choose this problem. In this problem, two series of values are given. They are x equals to 1 plus a square plus continuing up to infinity, and for the second series we have y equals to 1 plus b square plus continuing up to infinity, and the strict condition is minus 1 lesser than a lesser than 1, and minus 1 lesser than b lesser than 1. Okay, so these two given series are infinite series, and if we follow this series of values then they form a GP. That means we can say infinite GP. Okay, so with the help of these two infinite GP series we have to prove 1 plus ab plus a square b square plus continuing up to infinity xy by x plus y minus 1. That means the sum of this infinite GP is this. Okay, so let us study how we can solve this problem. Solution 1. Given x equals to 1 plus a squared plus continuing up to infinity, and y equals to 1 plus b squared plus continuing up to infinity, where the strict conditions are minus 1 lesser than a lesser than 1, and minus 1 lesser than b lesser than 1. Okay. Now, if we follow this series, then this series form an infinite GP, where the first term is a for both of these series, and the common ratio for the first series is a, and for the second series is b. Then, if we want to find the sum of this series, then we have to follow this formula. Okay, therefore x equals to 1 by 1 minus a, where first term a1 equals to 1 and common ratio r is a. Nothing is here means 1 is here, and after cross multiplication we get x into 1 minus a equals to 1 1s are 1. Then x minus ax equals to 1. This implies x minus 1 equals to ax. So this implies x minus 1 whole divided by x equals to a. So from the first relation we find the value of a, because to prove this we required a, that is why we find a. And for the second GP we have y equals to 1 by 1 minus b, where first term a1 is 1 and common ratio r is b. Nothing is here means 1 is here, So after cross multiplication, we get y into 1 minus b is equals to 1 ones are 1. This implies y minus by equals to 1. This implies y minus 1 equals to by. This implies y minus 1 whole divided by y equals to p. This is relation 2. Okay. So, with the help of given two infinite series, we find the value of a and b. Okay. Now, with the help of these two values a and b, we have to prove sum of this series, sum of this infinite series is xy by x plus y minus 1. Now, 1 plus ab plus a square b square plus continuing up to infinity. This is also an infinite GP where first term is 1 and common ratio is AB, where first term A1 is 1 and common ratio R is equals to AB. Since minus 1 lesser than A lesser than 1 and minus 1 lesser than B lesser than 1, therefore minus 1 is also lesser than AB, that means A into B, and AB is also lesser than 1. That means with the help of these given two strict conditions, we get this strict condition. That means this new strict condition, that is AB is greater than minus 1 and lesser than 1. Okay. Now we can apply this formula to find the sum of this GP series. So this equals to first term A, that means 1 by 1 minus R. R means AB. Okay. Now we can put the values of A and B. A means x minus 1 whole divided by x, and B means y minus 1 whole divided by y. This is equals to 1 minus product of these fractions is equals to product of the numerator whole divided by product of the denominator. That is why we get 1 minus x minus 1 whole into y minus 1 whole divided by xy. One divided by nothing is here means 1 is here. That is why LCM of 1 and xy is xy. So after subtraction we have xy minus x minus 1 into y minus 1 whole divided by xy. After this multiplication we get xy minus within first bracket xy minus y minus x plus 1. Xy minus xy plus y plus x minus 1 whole divided by xy. That means removing this bracket we get this. Now cancelling xy plus xy minus xy, we get 1 by x plus y minus 1 whole divided by xy. When this division turns into multiplication, then we have to write the reciprocal of this. That is why 1 into xy by x plus y minus 1, and multiplicating with y we get xy by x plus y minus 1. This is our required proof. So, with the help of these two given infinite GP, we prove the sum of this infinite GP is xy by x plus y minus 1, which is our required proof. Okay. For the second problem, a GP is given. That means that GP contains n terms. Okay. The sum of all the terms is given, that is S, and product of all the terms is P, and capital R represents sum of the reciprocals of all the terms. Okay. That means given a GP contains n terms where S represents sum of all the terms. Capital P product of all the terms, and capital R represents sum of the reciprocals of the terms. Okay, so these are the given three factors. That means a GP contains n terms where capital S represents sum of all the terms of that GP. That means sum of n terms of that GP. Capital P, the product of those n terms of the GP, and capital R represent sum of the reciprocals of all the terms of that GP. Okay. We have to prove P square equals to S by R whole to the power n. So, to find the sum of n numbers of terms of a GP, we have to know the first term and the common ratio of the GP. Okay. That is why first of all we have to let the first term of the GP be small a and common ratio be small r. Okay. So, therefore, S equals to a into r to the power n minus 1 whole divided by r minus 1 by following this formula, where here we consider common ratio r is greater than 1. Okay. Capital P is equals to a into ar into ar square into ar cube continuing into a into r to the power of n minus 1. That is sum of all the terms of a GP, and those terms are: first term is a, second term is ar, third term is ar square, fourth term is ar cube, and the nth term is a into r to the power n minus 1. Okay. So, if we follow this product, then there are n numbers of a in the product form. and product of n numbers of A is denoted by A to the power n. That is why we can write P equals to A to the power n into, and when we want to find the product of r square, r cube continuing r to the power of n minus 1, then they are looking like r to the power 1 into r square into r cube continuing r to the power of n minus 1. Okay. This imply P equals to A to the power n into r to the power of 1 plus 2 plus 3 plus continuing plus n minus 1. That means when the bases are equal, then the product of these terms are common base sum of the powers. Now the powers are looking like 1 plus 2 plus 3 plus continuing plus say x is equals to x into x plus 1 whole divided by 2. Already we know this form of addition of arithmetic progression. Okay, so with the help of this additional or summation formula, we can write P is equals to A to the power n into r to the power of n minus 1 whole into n minus 1 plus 1 whole divided by 2. This implies P equals to A to the power n into r to the power of n minus 1 into n whole divided by 2. Cancelling this plus 1 and minus 1. So P becomes A to the power n into r to the power of n minus 1 into n whole divided by 2. R represents sum of the reciprocals of the terms in that GP. That is R equals to 1 by A plus 1 by AR plus 1 by AR square plus 1 by AR cube plus continuing plus 1 by A into r to the power of n minus 1. Now, if we follow this series, then this is also a GP where the first term is 1 by A and common ratio is 1 by R. This is also a GP where first term A1 is 1 by A and common ratio equals to 1 by R. Okay. So, in this case, that means sum of for S equals to A into r to the power n minus 1 whole divided by r minus 1, we consider r is greater than 1. That is why here the common ratio 1 by r will be lesser than 1 as r is greater than 1. So, capital R becomes 1 by A whole into 1 minus 1 by small r whole to the power n whole divided by 1 minus 1 by r by following this formula. This implies capital R equals to 1 by a whole into 1 minus 1 by r whole to the power n means 1 by r to the power n. And subtracting, nothing is here means 1 is here. So the LCM of 1 and r is r, and in the numerator there will be r minus 1. Similarly, nothing is here means 1 is here. So the LCM of 1 and r to the power n is r to the power n. So after subtracting, we have r to the power n as denominator, and in the numerator this will be r to the power n minus 1 whole divided by r minus 1 whole divided by r. This implies capital R equals to 1. Now after multiplication, in the numerator we get r to the power n minus 1 whole divided by a into r to the power n whole divided by r minus 1 whole divided by r. So this implies capital R equals to, now when this division turns into multiplication, then we have to write the reciprocal of this. That is why capital R equals to r to the power n minus 1 whole divided by a into r to the power n into small r by r minus 1. So capital R becomes small r into small r to the power n minus 1 whole divided by a into r to the power n whole into r minus 1. So the given sum S, product of all the terms P and sum of the reciprocals of all the terms are this, this and this. Now with the help of these relations, we have to prove this thing, that is P square equals to S by R whole to the power n. So we get these three relations, that is S equals to A into R to the power n minus 1 whole divided by R minus 1, P equals to A to the power n into R to the power of n into n minus 1 whole divided by 2, and capital R equals to R into R to the power n minus 1 whole divided by A into R to the power n into R minus 1. Okay. Now we have to prove P square equals to S by R whole to the power n. So therefore P square equals to, P means A to the power n into R to the power of n into n minus 1 whole divided by 2 whole square equals to, this is like A to the power n whole square into R to the power of n into n minus 1 whole divided by 2 whole square. That is A to the power n whole square means A to the power 2n into R to the power of n into n minus 1 by 2 into 2. This is also R to the power of product of these powers by following this formula. P to the power x whole to the power y is equals to P to the power of xy. By following this exponent formula, we can find the product like this way. Cancelling these two, we get A to the power 2n into R to the power of n into n minus 1. So this P square is equals to A to the power 2n into R to the power of n into n minus 1. and S by R is equals to A into R to the power n minus 1 whole divided by R minus 1 divided by A in R into R to the power n minus 1 whole divided by A into R to the power n into R minus 1. Now, when this division turns into multiplication, then we have to write the reciprocal of this. So, S by R equals to A into R to the power n minus 1 whole divided by R minus 1 into A into R to the power n into R minus 1 whole divided by R into R to the power n minus 1. Okay. So, when this division turns into multiplication, then we have to write the reciprocal of this. We can cancel this R minus 1 from numerator and denominator, then R to the power n minus 1 from numerator and denominator. So, S by R becomes A into A will give A square into R to the power n by R will give R to the power of n minus 1 by following this identity. P to the power x by P to the power y equals to P to the power of x minus y by following this exponent formula. R to the power n by R means R to the power of n minus 1. So, S by R whole to the power n is equals to a square into R to the power n minus 1 whole to the power n. So, this implies a square whole to the power n, a square whole to the power n into R to the power n minus 1 whole to the power n. Okay. So, a square whole to the power n into R to the power n minus 1 whole to the power n. This implies a to the power 2n. R to the power R a square whole to the power n is equals to a to the power 2n into R to the power of n into n minus 1. Okay. So, S by R whole to the power n becomes a to the power 2n into R to the power of n into n minus 1. This is similar with this. So, thus we get P square is equals to S by R whole to the power n. This is the required proof. So, this is the way by which we can prove P square is equals to S by R whole to the power n. Okay. So, when you want to solve this kind of problem, then first of all we have to simplify those problems as this simpler form, and then we have to follow these procedures. Okay. In problem number 3, it is given that A, B, C are in GP. So, A, B, C are in GP and X, Y are the respective arithmetic means of A and B and B and C. That is, X is the arithmetic mean of AB and Y is the arithmetic mean of BC. With the help of these conditions, we have to prove 1 by x plus 1 by y is equals to 2 by b and a by x plus c by y equals to 2. Okay. So, let us study how we can prove this. Solution 3. Given A, B, C are in GP, X is the arithmetic mean, that is AM of AB, and Y is the arithmetic mean of BC. Okay. So, these are the given conditions. In our previous class, we learned that arithmetic mean or AM of two numbers P and Q is P plus Q whole divided by 2. In our previous class, we learned that arithmetic mean of two numbers P and Q is P plus Q whole divided by 2. So, with the help of this thing, we can write X is equals to A plus B whole divided by 2 and Y is equals to B plus C whole divided by 2. Okay. Since A, B, C are in GP, therefore B equals to AR and C equals to AR square, where let R be the common ratio. Okay. Since ABC are in since ABC are in GP, we can let B equals to AR and C equals to AR square, where R be the common ratio. Now, X becomes A plus AR. That means putting B equals to AR imply X equals to A into 1 plus R whole divided by 2 and Y equals to B plus C whole divided by 2. B means AR and C means AR square. So, AR plus AR square whole divided by 2. Now, if we take AR as the common factor from these two, we get AR whole into 1 plus R whole divided by 2. In these two terms, AR and AR square, AR is the common factor. That is why we can write Y is equals to AR whole into 1 plus R whole divided by 2. Okay. Now, for the first proof, LHS equals to 1 by X plus 1 by Y is equals to 1 by A into 1 plus R whole divided by 2 plus Y means AR into 1 plus R whole divided by 2. So, reciprocal of this will give 2 by A into 1 plus R and reciprocal of this will give 2 by AR into 1 plus R. Now, the denominators are A into 1 plus R and AR into 1 plus R. The LCM of these two is AR into 1 plus R. Dividing this LCM by this, we get R. So, 2 into R will give 2R and this divided by this will give 1. So, this becomes 2. Now, we can take 2 as the common factor from this. After taking 2 as the common factor, we get 2 into R plus 1 whole divided by AR into R plus 1. Cancelling this R plus 1 from numerator and denominator, we get 2 by AR. AR means B, that is why we can write 2 by B, which is the right hand side item. So, this is equals to RHS. Proved. For the second proof, LHS equals to A by X plus C by Y. So, A by X, X means A into 1 plus R whole divided by 2 plus C, C means AR square whole divided by Y, Y means AR into 1 plus R whole divided by 2. When this division turns into multiplication, then we have to write the reciprocal of this. That is why A into 2 by A into 1 plus R plus. Similarly, when this division turns into multiplication, we have to write the reciprocal of this. That is why AR square into 2 by AR into 1 plus R. Cancelling this A from numerator and denominator and then R and R square, we get 2 by 1 plus R plus 2 into R, that is 2R by 1 plus R. Now the denominators are same, that is why common denominator and then sum of the numerators. Okay, so we get 2 plus 2R whole divided by 1 plus R. Here 2 is the common factor and after taking 2 as the common factor, we get rest of the term as 1 plus R. So, this becomes 2 into 1 plus R and in the denominator there is 1 plus R. Cancelling this 1 plus R from numerator and denominator, we get 2, which is equal to the RHS item. Okay, so this is the way by which when some conditions are given and the conditions here are ABC are in GP and X is the arithmetic mean of B and arithmetic mean of A and B and Y is the arithmetic mean of B and C. With the help of these three conditions, that is ABC are in GP, X is the arithmetic mean of AB, Y is the arithmetic mean of BC. With the help of these conditions, we prove these two expressions. Okay, that is 1 by X plus 1 by Y equals to 2 by B and 1 A by X plus C by Y equals to 2. Okay. In our next class, we will learn the combination of arithmetic progression and geometric progression, that is known as arithmetico-geometric progression. Okay.